Oh, by the way, have you guys had your breakfast or not? Should I open a Google form and then everyone has to fill? I have had my. I hope everybody can see this. Okay, I'm going to close the chat box. All right. This is microprocessor class. As I mentioned to you last time that wait, why it's not showing. Okay, this is my microprocessor class. My name is Muhammad Shahid Zafin Rusli. This is under my name is my it's my what do you call it, my room number. But I very rarely spend my time there. I mean, I don't sit in my office, but I most of the time I think we have gone through all this in our CQI, sorry, in our course information CI, and these are the things that we need to know, prerequisites. Okay, you need to know. You have to recall your knowledge on number representation, coding, realization of simple logic circuits, flip-flops, counters, and register transfer logic. Okay, right. So yeah, I have also shared with you the textbook that I use heavily for this work, for this job. Sorry, for this course. Okay. So let's start. Oh wait, what happened now? Sorry, cannot help with the cat. Okay. Right. So okay. So computer. As you know, computer. What does it do? It does data processing and data storage. Okay, data processing and data storage, which means that once it gets its instruction to do, okay, it does the processing that is intended for CPU to do it, and then after that it stores the data. Okay, but to do the processing, it requires uh, what call it it requires program or code. Okay. Oh, okay. Later on, we understand about data and the program or the code. The code. Okay. We will be able to differentiate this terminology throughout the course. We will use these two terminology: data and um, code or program. Okay, so you will always regularly hear this, but so you have to remember this. Okay, because it's very important for this course to be able to distinguish between these two. Okay, so okay, as of now, what you have to understand is computer do data processing, and after processing, it does storage, storing the data. Okay, what involves in the basic function of computer? It has, of course, other than these two, it has data movement. Okay, where does it move from and to? Okay, it moves between memory and CPU. Okay, for those who does not or who do not know CPU is, or can anybody write in the chat box what is CPU? I hope everybody knows how to knows what is CPU. Okay, data processing unit. Somebody answer data processing unit. Okay. Okay, I think everybody knows, of course, because you are using the computer. Of course, you know the CPU, right? Okay, and there's a control. Control, but where does control? Where is control mechanism happen? Where does it happen? It happens in the CPU itself. CPU, yeah, the control. In fact, in CPU there is a unit that is called control unit. Yeah, so control unit. This control unit is the brain of the computer. Of any processor or any system, you have to have a quite a complex system. It has to have a brain. So the brain is a CPU or the control unit inside CPU itself. Okay. Okay. Okay, classification of computers. I think you have gone through these servers, desktop, laptops. They are just type of computers. The most simple, the simplest computers we can say is embedded system. So this is the one that you're learning. You're going to learn in this course. You start with the small or the simplest computer type first. Okay, say embedded system. Okay, so called. So our microprocessor is an embedded system. But what differs it from the other computer classification is because of the specific application that it has. Okay, right? Meaning that when you write a program in your microprocessor, it means that you want it to run on you want it to run a specific application. Okay, one or two maximum two application. For example, you want your microprocessor um, to do temperature sensing. Okay, temperature sensing, light sensing. So you write a program, you connect the sensor to your microprocessor, and then and then the code and then the sensor will be read by the I/O port, the input output port, and meaning that it is being sensed. The input is being sensed by the I/O, and then processed by the CPU, and then the data when after the processing is done, the data is being stored in the memory. So that's how CPU. That's why we learn in the first slide that CPU or computer does it processing and storage. Okay. These are just a simple or the sample or the examples of embedded system that are in the market today. Okay, you can see a lot of microprocessor-based systems. In fact, we are using it in our daily life. Okay, in fact, your computer, your handphone, uh, your um, your smartwatch, for example. Okay, smartwatch. They are all embedded systems. Inside inside the watch itself, it has um, a lot of processor or microprocessor-based systems in which every system runs dedicated application. Okay, so now the application or now the technology has evolved to the state or to the extent that we have SoC now. Okay, if you ever heard of system on chip. Okay, so this system on chip is able to gather all systems. Okay, specific application systems running on a chip. Okay, multiple system running on a chip. So that's called system on chip. Right. Okay. Again, this is what I've told you about. I've told you uh, about the embedded system. Okay, these are just another samples of embedded system. You can see in your phone alone, there's numerous numbers of embedded applications. And even in aviation, for example, in aircraft, in A380 computer, in A380 Airbus A380. Okay, it has about 5,000 different systems running. When it is an airborne, meaning that when it is carrying you, taking you from point A to point B, so it has about 5,000 systems, embedded systems running. Oh, yeah, wait. Okay, so yeah, so that's the point. That's the point of having embedded system right now. Okay, just another example. Can read through automatic on in this one is an automotive. Okay, in fact, modern cars they have MCU right now. They no longer operate on this heavy machinery or stuff like I don't know about engine so much. Okay, but you cannot you hardly see if your car breaks down, you cannot simply go to any um, I mean, of course, the luxury cars lah. They cannot simply go to any workshop and then let it fix. Okay, because they have MCU, so they have to go um, to the proper workshop. Okay, to the proper um, the owner of the car brand and have it fixed there because they only they can have the system access the MCU. What is MCU? Anybody knows about MCU? What is MCU? Please right? Or please say something. Other than that,
Microcontroller unit.
lain microcontroller unit. Somebody says microcontroller unit. Micro. Okay, there's no difference. Microcontroller one word, microcontroller two word. So okay. Any other answer? I think you guys are googling. What is MCU? Write that down now. No one else. Want to try? It's master control unit. Yeah, microprocessor control unit, master control unit, some sort of like that. Okay. So basically, this is an embedded system. Okay, meaning that one control unit will handle maybe fuel injection. Okay. For example, here you have for example, let's look at the most common ones. In terms of vehicle energy, uh, which one we are quite common with? Okay, for example, very simple one, DVD playback and radios. In fact, that alone is an embedded system. Okay, because it only um, runs or it only executes one simple or not one simple one specific application. Okay. Also for seating system, yes, the seating system that you adjust according to your seats, uh, according to your preference, right? So, for example, one for cars like luxury cars like Mercedes, BMW, you can have like two or three settings. Okay, so the first guy or of course the main driver can enter his own setting. So when you sit, you just choose your your button, and then it will automatically adjust for you. And maybe person number two who sit there and can have another setting, maybe they can have about few settings like that. Okay, okay, yeah. Memory function setting, climate control. Yeah, there's a lot. I mean, not just in automotive. There's a lot more applications, not just in automotive. But I'm not sure where climate control is applied in automotive. I don't know. Okay, can you control a climate using in embedded in automotive? I don't think so, right?
Cannot.
Okay, right. Okay. Right. This is just another automotive. There's a lot of applications there. Right, specific purpose. Okay, this is specific purpose processors in embedded system. Okay, for embedded system, you cannot just have an Arduino to control digital signal processor. Okay, for example, a graphic processor or something like programmable logic controller, because it will have a different architecture that needs to cater or that needs to be able to process the data according to its needs. For example, digital signal processor. Arduino cannot simply do that. It has to have a specific processor for it. Okay. Same goes to graphic processor. Okay. So your GPU, for example, graphic processor. Those who has a like gaming laptop. Okay, gaming laptop. So those graphic processors is needed just to do graphics for your games. So that's why Arduino cannot simply do that, because Arduino, even though it is an embedded system, but it does not have the capacity or the facilities to do the graphics processing. Okay, this is a general purpose processor versus embedded processor. General purpose processor is like the regular CPU that you have in your laptop. Okay, CPU, just general CPU, and versus the embedded system. Okay, so when we talk about embedded system, we talk about the CPU in a microcontroller or microprocessor. When we talk about general purpose processor, there we are referring to a general purpose processor in a laptop, something like this. Okay, because the CPU in a laptop, in your laptop. Okay, you have Intel i7, Intel i5, Intel i8, right? They can run a full set of a general set of applications, meaning that any application you can run on it. Okay, you can open a MATLAB with that. You can open Microsoft Word with that. You can run a calculator. You can open a Google Chrome. Okay, you can play games with that. Yeah, things like that. But for embedded system, when we talk about embedded system, they also have controller, but the controller is for for one or two applications that is developed for it. But often when we but why what is the necessary or what is the necessity to 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 design an embedded system as compared to general purpose processor? What do you guys think about this? Why people want to have an embedded system? Why don't we just use the general purpose processor? Because general purpose processor we can always reconfigure and write the other code. I mean other code for that, right? Because it supports the any application. But for embedded, it's very limited. But why? Faster, good, cheap, cost saving, alright, updated. Other than that, yeah, okay, affordable, specific tasks, less complicated. Right. Okay, that's very good. Many of you understand this very well. Okay, yes, that's the main purpose. The main feature is because we want it to be fast. Okay, it's a speed issue, of course, because there's an answer there. Okay, anyway, but but in any case, but at least you guys understand the value or the main feature of this system. Okay. Skip this. You can just answer. You can just look at this. Okay, so general computer system, you can see there's a quad core or dual core system, okay, in the CPU like this. So if you go for further, let's say if you those who are from SKEL, right? I know many of you are a majority of you are from SKEE. Those who are doing SKEL, if you go further into my computer engineering and you take my course in embedded processor system later on in second semester, okay, or to take or those taking electronic system design, you will also see me in year 4. You can see that we're going to learn that how we can boost the performance of this quad core or dual core processor. Okay, this big processor like this, we can boost the performance using hyper threading, and multi-threading and stuff like this. Okay. In fact, there's a lot of techniques to do to boost the performance of a computer like this. Okay. It's quite interesting, and actually, it's quite interesting. Okay. Okay. This is a complex CPU. You can see there's a PCIe bus that is common. Okay, this is quite common right now, where PCIe is a bus expansion slot. Okay, that you connect the CPU. You connect the CPU to many other peripherals outside PCIe, right? And okay, this one is just to show the many ports, meaning the I/O ports. When we say ports, it means I/O ports, input/output ports connected to it. Correct. Uh, okay, so this one is just to simplify understanding of CPU of a computer system. So basic computer system must have the CPU, okay, memory, and input/output. Input/output is the one that you you have seen in the previous slides, right? Okay. CPU controls the operation, memory stores and retrieves data, input/output move the data between the external environment, meaning they're using the peripherals um, or external device. Okay. For this address and data and control bus, okay, you see that when you see this one, okay, you see this symbol, it means that they are, this one, it means that they are dual, what call it, dual way, okay, dual direction, meaning that, for example, from input, output peripherals can go to control bus, and control bus uh, uh, value or data can travel to input output as well. Meaning that if it goes from input to the control bus, and then it can goes to memory, or retrieve back from memory back to control bus, and then we process in the CPU and send back after CPU do the processing. It's being sent back to the control bus maybe, or to the data bus, and then being stored in memory, for example. Okay, so that is a dual direction. But for this one, address bus, okay, you can see that address bus is one one way. It's one way. Okay. Later we're going to learn this, but it's enough for you to understand. There's a CPU, memory, input output, and buses. Okay. What are the three types of buses? Address bus, data bus, and control bus. What is the address bus? Okay, later on we're going to talk about it. So, CPU. Okay, so it controls the operation. Of course, a control unit. The name itself speaks for itself, right? Control processing unit. So central processing unit. It means that control the operation. Yeah? It controls the operation of the entire platform or entire chip. Okay, so this is the basic what do you call it? Basic structure of a CPU. In which you can see the registers, control unit, and ALU. This one is inside the CPU. Okay? The control unit is the one that controls everything. Okay, inside there's a register. What is registers? What are registers? Okay, we'll talk about it later on. Enough for you to understand that inside CPU there are three things: registers, control unit, and ALU. What is ALU? I hope everybody knows. If you haven't if you haven't heard of it, I hope you withdraw from this course and go back to second year. Okay. This one arithmetic logic unit. Yeah, okay. Fail, not pass. Arithmetic, you spell it wrongly. Go back to second year. Okay. Arithmetic. Okay. Address bus, data bus, and control bus. Okay. Okay, that's okay. I'm just kidding. All right. Okay. Can you see that going out going out and in of address of the CPU is the address bus and data bus and control bus. Okay. Why is it necessary to have this address bus, data bus, and control bus? Okay. I want to ask first, what do you understand between address bus and data bus? If you have gone through the slide, maybe you understand. Can somebody please answer? Maybe open a chat box. Sorry, open a. Can I hear your voice? Somebody please speak up.
I
I
think
think it's better.
the address
Yeah.
bus
Who is this?
selects.
Who is this? Introduce your name.
Oh, I am Nick Umar,
Nick Omar. Okay, Omar.
and I think the address bus selects the components to which the data bus will send data to the
Sorry.
component.
I miss your name. Come again.
Okay, so I think the address bus is used to select which
Uh-huh.
component to send data, where the data bus will send that data to the selected address. That's what I think.
Okay. All right. So how about data bus? So meaning that you're
Um,
saying the address bus is between what and what?
uh, I think the address bus is between the
It
CPU
is between CPU and.
and the whole peripherals of components.
Oh, okay. CPU and the whole components.
Yeah,
Okay, meaning that it's taking something, maybe it's taking value, a packet, or maybe a Maggi or maybe a nasi lemak, okay,
yeah.
between CPU and the other peripherals. Okay, how about data bus?
So once the address bus selects where to send that stuff, that Maggie and nasi lemak, then the
Mm.
data bus will send the thing.
Then the data bus will send the thing.
Yeah,
Oh, okay. All right. So your understanding is that way. Okay.
yeah.
So okay, there are so many. Okay, thank you. So many
Welcome.
other response here. Uh, Let me read. Data bus is where data travels between CPU and memory. Data bus is where data travels between CPU and memory. Address bus is where CPU selects data from memory. Address bus is where CPU selects data from memory using specific address. Almost there. Okay, so let's at least you have some idea. Okay, but you guys have some idea lah. But okay, let's see if you get it correct or wrong. Okay, but later on in the end of this lecture, we're going to ask you again. What do you understand for this address bus and data bus? Okay, so let's see how do you understand, or maybe your understanding is the same, like after, like before and after the same. So I think something's wrong with my lecture. Okay. Let's look at here. What does ALU do? It performs the arithmetic and logical operation within the CPU. So of course, because we do the processing, right? So the data is being fed into the CPU, so the CPU needs to do some processing. What does it do? That's arithmetic or logical operation, right? Then the control unit. It synchronizes and controls the overall operation of the microprocessor system. It decodes instruction and passes the necessary control signals to control unit. What does decode instruction anyway? Wow, instruction. What instruction? Okay, later on we're going to see that. Okay, so please remember this word, decode instruction. What does decode instruction means here? Okay, why is it necessary to have the instruction? Okay, and where comes the instruction from? Where does the instruction comes from? Okay, so we need to know this. So the keyword here is decode instruction. Okay, and register. Oh, so now we know that a register is a internal storage. So that means that CPU itself has a memory. Okay, has a memory inside it. So maybe you learn in, maybe you get you like what you know, right? See, in your CPU, in your laptop, it has a cache, right? Something like cache. Yeah, it's simply like that. It means that cache is a memory, right? It's a temporary memory. It's a memory that resides very close to CPU. So that is something like this. So cache is the register is something like cache, you know. Okay, because they function the same. Their functions are the same. They store some data, some memory value. I don't know what value. Later on, we're going to say to discuss about this. But but it's a storage. Okay, what type of storage? Because we also have other storage outside the CPU. Okay, so we'll talk about this. Okay, control instruction registers. Okay, I think this one is should you understand now? Okay. These are you. What you have to understand is that what this slide says to you is that control instruction registers. This one happens in CPU. This one is what happens in CPU, and you do not have to know what is actually happening. Okay, because you cannot even see what does instruction register do. What is a program count? What does a program counter do? Or what is it? What the value is it currently? You don't have to do. You don't have to know now. But these user visible registers are the things that you need to know in order for you to make sure the data and the processing is correct. Okay, it's running correctly. Okay, so this one we will see throughout the course. We will see. I think in the first half of the half of the semester we're going to see this a lot because you're going to run with your AVR Atmel Studio. Okay, you will see this a lot. Okay, we are going to show that in a simulator. It will be very interesting to see that. Right? Microprocessor basic concept, right? Okay, the CPU is connected to three buses, right? Address bus, data bus, and control bus. Okay, this one is one directional. Okay, so the CPU has instruct something. Okay, on the bus, they put something on the bus. Put some, we call it address value on the bus, and then it goes to a memory. Okay, to a memory. But what type of memory? Okay, we have other memory types. To address or to collect from the memory. We need to collect something. Why CPU instruct in something on the address bus? Because it needs to collect something from the bus, from the memory. Okay, from the memory location. And then there's a data bus. Okay, so of course when you go to, for example, you can imagine it in this way. CPU is a master that instructs something to something to be done. Okay, so it says that okay, please go to uh, to to a memory location number 2 or number 3, or for example somebody instruct you to how to say this. There's a lot of courier service right now. Okay, I don't know how to put this in live chronology. Yeah. Um, okay, somebody wants to access. Somebody is called CPU wants to access the data in house number 2, Jalan Pulai Indah, in Skudai. Okay, so what it does, CPU uh, tells the courier service, okay, the courier service or the courier person to go to this number, at this address, number 2, Jalan Pulai Indah, 5, for example, Skudai. So what it does is that this courier service, this courier guy will go to this address, okay, and go to this address. I mean the address that is being put by CPU, and then what does CPU ask it to do? Okay, take a parcel from the residents in that house. So maybe there's something that this resident has. Okay, so this resident has a parcel for CPU. So the address bus go to the address, and then it left. Okay, there's nothing else for the address bus to do, right? So when they take the parcel, so now the owner of the house know that the parcel must be sent to somebody, right? So sorry, must be sent to the CPU, but it does not use the address bus. Okay, in fact it gives another courier service to send the parcel to. So it uses the data bus parser. Sorry, data bus courier service, some kind of. Okay, so and then so the data or the parcel from the owner of the house or from the resident will be sent to the CPU through data bus courier service, something like that. Okay, as of control bus. Okay, control bus is the what do you call it as a control, meaning that when CPU wants to access number 2 Jalan Pulai Indah 5, okay, all the other memory location must be locked. Okay, cannot accept, cannot send something or cannot send anything. Okay, so that is control. Or that is that at the same time when address is being put here, at control bus need to be set to tell everyone not, okay, please lock your door. Okay, please lock your door. Do not send anything, any parcel out of without the instruction from CPU. So this is what this is what the CPU tells the others. Okay, but using control bus. It's not everything lump on address bus. So address bus send every instruction. No. Okay, address bus is very dedicated for address only. Okay, so that once the memory reads, it only reads from the address bus. But for control bus, it's dedicated for control the operation, whether to log or whether, okay, now you send, now you read, now you write, something like that. Yeah? So that's how control bus run the operation. Okay, so you can see that there are concept of what are the peripherals or the modules or the blocks that connected to the CPU. Okay, you can see there's a ROM here. There's another ROM. Okay, and so the RAM. Okay, these three green, what do you call it? These light green blocks are memory. Okay, they're memory. But what are the difference? There's a difference between ROM and RAM, right? Okay, and this one for input output, because of course the memory, the data that is being read from the external environment must be stored somewhere. Okay, so this or the memory addressing, or we address the ports that is connected to the to the port, to the CPU or to the microcontroller. It needs to have the memory address also. So this is where input output is used for. Okay. Okay, so far so good. Do you have any question? Please write if you have any question, or you can stop me right now. No? Okay. Okay, now before I proceed, I would like to stop here. Oh, 9:50, very good timing. So we are quite almost half of the lecture already. So first quiz. Okay. So first quiz, I will share with you this form. Make sure that you write this is your first quiz. Please answer this. I give you from 9:50 until 9:52. Very short one. Make sure you write your full name. Name the microprocessor that we study in this course. CPU, RAM. Is this one? What do you guess answer? CPU. What I mean? Okay. Okay, well, so now I know you guess. Atmega, 32, Atmel. Oh, even the name of the manufacturer also comes out. It's actually Atmega 32, guys. Okay, Atmega 32. Okay, very good. Okay, many of you understand this. Okay, CPU. CPU is not the microprocessor. CPU is a general name for for the processor, right? Um, That's a component. CPU. Okay, CPU, RAM, ROM, CPU. Oh, it's getting. I don't know. Getting horrible. Embedded system. That's even worse. MCU. Yes. Huh? Is that an answer or not, Alia? Okay. ADMEL32, ADMEL, AVR. AVR is a simulator, guys. CPU, data processing, embedded system, embedded system, embedded system. Okay, guys. So please, the answer is ADMEL32. That's the name of the microprocessor that I asked you, that I told you in our first class. Yeah. Just the use of CPU. Okay. Yes. Okay. This one is okay. I made a mistake, so I will correct it later. Okay. So the use of CPU is okay. Somebody please answer. What's the answer?
Data manipulation.
Data manipulation. Yes, that's actually data processing, right?
And
Another one is
good storage.
okay. That's a good guess, but that's wrong. Okay. So now, cold storage and data storage. Okay, there's a difference. Okay, is data storage. Okay, you remember in the first slide it says data processing and data storing.
Manipulation.
Right? Data storing, right? Storing and processing. Data, not code. Okay, I will explain later what is code. Okay, like I told you last time in this previously, data and code. You have to remember what is the difference between data and code. Okay, so it's actually data manipulation and data storage. Now let's look at this one. What is the main feature of the embedded system?
Doctor,
Yeah.
for the data storage, is it ROM?
Okay, that's a good question. When we say data storage, okay, meaning that it stores after the operation is being done, the CPU will instruct to the storing where to store it. Okay, of course it is in RAM. Okay, later on we'll learn when you simulate the code, when you simulate your program later on using ADMEL. Okay, I think maybe next week we can start doing that. Okay, I hope everybody has installed your ADMEL Studio. I will show my simulation and you can follow lah. Okay. And one more thing. I hope anybody who knows using Discord. Anyone you knows using Discord?
I do.
Okay. I have to be honest with you. Okay, I have to be honest with you guys. I've never used Discord before. So I hope because I heard it's very interesting to use. So please teach me how to do that. Okay, and what I understand is that maximum number of sharing can be only maximum 50, but I think somebody can share their window to other friends, right? So in that way we can solve the case where because our class is more than 50, we are 60 something. Okay, so we can share. And maybe you guys can share that. So please teach me. I hope we can do a breakout room there, and okay, I think it's very interesting to do that. Discord. Okay, so data storing is in ROM. It's in RAM, and code storage is in ROM. So I will later tell you about this. Okay. What is the main feature of the embedded system? The main feature of embedded system run at most two special application. Correct. This is correct. Okay. 71% of you got it correct. 72. And clearly somebody is sleeping. Maybe how many of you? 5 of you are still sleeping. Running a 42-kilometer marathon. Okay. Then finally, applications that run in general purpose processors are always required to execute faster than in embedded system. So which one? Is it true or false?
Oh,
The answer is applications that run in general purpose processor are always required to execute faster. Of course, it's not. Okay, because that's the reason why we use or we introduce or we use embedded processor. Embedded processor is required to run faster because the times matters. Okay, time matters to this for decision making to be done. That's why embedded system is much faster to do. That's why we have more embedded system than the CPU or the general purpose processor on an aviation, on an aircraft. Okay, although there's a if you see A380, I can see that stack of 4 CPUs at the cockpit. Okay, when we watch Discovery Channel, like National Geographic Channel, I love to watch aviation, second from disaster, air crash investigation, things like that. So it's quite interesting to understand the embedded system inside the aircraft, right? Okay, so it is not always true. Okay, so of course this is false. We want it to be. The fact is that the embedded system is always required to execute faster. Okay, all right. So I think. Okay, let's go back to this slide. Can you? Now I'm opening my slide now. Can you see, guys?
Yes, sir.
All right, good. So, are you okay to continue, or you wanna take some rest?
Continue.
Okay. All right,
Continue.
continue. All right. Okay. All right. So, okay. Now, just now we saw the question about ROM and RAM, right? So, sorry, about what I mean is code storage and data storage. So here you can see. Now let's go to here. Okay. Now in instruction program, it is installed in ROM. This is where you write your program. You write your program. Let's say you write a program. Okay, please do operation add operation 5 plus 5. Okay, 5 add with 5. So where do you write the program? You write here. So of course you write on your interface, in your computer. But where is it being stored? After you store the application, so you store the program, you store it here in instruction program memory. And where is it? It is in ROM. Yes, it is in ROM. After that, but the data, where is the data? Number 5. That 5, for example, you asked to do operation 5 plus 7, right? Somebody please. Okay, thank you. Okay, the instruction is to do add operation. But where is it being put? Where is 5 and 7 is being put? 5 and 7 is being put here in data memory. Data memory is in RAM. Random access memory. Okay, and this one is random read-only memory. Sorry, read-only memory. Okay. Okay, you get it, guys? So this is how CPU access the program. So when it wants to, like I told you, okay, CPU needs to do the operation, right? CPU needs to have the instruction. What instruction you want me to do? Okay, so it fetch the instruction from ROM. So your instruction is to do, please do addition of 5 and 7. So where you write your instruction? Here in ROM, right? The instruction is being stored in ROM. But CPU does not have it. CPU fetch the instruction, okay, through address pass, because CPU knows that, oh, your instruction step at memory location, for example, at address number 10. Okay, or you can imagine the memory is like a rack, a stack of rack. Okay, rack where you put your books, right? Yeah, you can imagine a very high, a very huge, a very, very high rack, okay, to store your memory. So it is being put in a stack way, in a stack manner. It's stack from, let's say, from 0, 1, 2, 3. So stack level 0, stack level 1, stack level 2, 3, and so forth, until maybe stack number 100. 1,000 or something. So you can have like 1,000 stacks, right? So memory is being your instruction is being stored there. But what instruction? It is being stored in the type of hexadecimal. So your instruction will be translated first into a hexadecimal number. Okay, we will talk about this later, but it's enough for you to understand that your instruction is being stored in the row in the stack, right? And CPU access it through the number of the stack. Where is it? I cannot hear anything. Guys, can you hear me?
No, we can hear.
Okay. Alright.
I think
Somebody else
it's
cannot hear.
yeah,
Okay.
personal problem.
Maybe you need to restart, or maybe you need to log in. Okay, so this is how the instruction is being fetched from them by the CPU. Okay, and then it's being read by the CPU, and CPU understand it by decoding it. That's why we talked about decode instruction. So previously, I still cannot. I cannot do. I don't know. Please, guys, please write. Please write a question. Says that.
Turn on your volume.
Turn on your volume. Yes, correct. Maybe. Okay. Embedded system. I don't know. It is going to take a year. So see you next semester. Okay. Instruction program. All right. So when the instruction is being fetched into CPU decode it, and then now it understand that CPU understand that I need to do add operation between 5 and 7. So but where is 5 located? 5 and 7 is not put here, not in instruction. But 5 is a data, right? 7 also is a data. So what it does, CPU sends another instruction to fetch 5 and 7 from the RAM, from data memory. So it's RAM lah. Okay. How it is being sent? How it is being located? The arrangement of 5 and 7, where 5, where is 5, where is 7? Okay, that one later on when you do the code, you can understand that when you do the program. Okay. So instruction, we often use it as program memory or code memory. Right? So this is how we define it. Okay. So throughout the semester, I will always use the word program memory, or data program memory, or code memory. Okay, or data memory. So when I say program, it means instruction or program here from ROM. Okay, when I say data, it's always from RAM. Data memory is always RAM. Understand this? Okay. Difference between instruction and data. I just told you, right? The program or the write that you write, okay? The program that you write, like I told you. Now, first instruction is to your instruction in your program you write in your simulation. Okay, you say that please add 5 and 7. That's one instruction. Second instruction, please multiply the results. Excuse me. Please multiply the result of 5 and 7 with 10. The second instruction. Third instruction, please store the results in a register in CPU. That's third instruction. So that instruction is the one that you write. You write the program. You write what you want to do, what you want your microprocessor to do. Understand? But data is the value that you want it to operate. For example, just now in instruction 1, we use 5 and 7, right? So 5 and 7 is being stored in data. So instruction D, come again. Let me read. So instruction is the instruction set. Okay, correct. So the instruction is the kind of instruction set. Okay, when you write the program, you write into languages, right? In the first program, in the first lecture, I told you about assembly language and high-level language program, right? So one is high-level language, meaning that when you write the code in C, okay, you do not write the instruction set. Instruction set is what you find in assembly language, right? So yeah, basically it is instruction set, okay. But the instruction set that you see in the manual, okay, the manual of Admeka 32 is for assembly language. But that is the code, that is the instruction that you're going to use to write your program. Yes. Okay, there's 100 of instruction sets there. You're going to use the instruction set to write your program. Meaning, for example, to do add operation, addition operation between 5 and 7. What instruction set you need to do? You have to find it from the list of the instruction set. We're going to learn it throughout the half of this semester. Okay, I will tell you. I will show you how to do it. Okay, but you also have to play your part. You have to play around with the instruction set. Okay, so the number, the data is the one is instruction program. Okay, sorry. Yeah. So the program is here and data is here. Okay. So let's move on. This is a memory. Yeah. Okay. Now I hope everybody has gone through this. Okay. Please understand this very clearly. Okay. The memory address is like this type. I just told you about this, right? The memory address is like this type. You can imagine having a rack of 1,000 levels of racks, right? Memory address 0 represents rack 0, meaning the lowest or the highest. So in memory, we arrange it such that memory address 0 starts from the top, okay? Top to bottom, top down, yeah? The control bus has nothing to do with instruction and data. The control bus is only being used by the CPU, okay, to read or write, okay. So read and write, you can find for example, like this. When we do instruction, when CPU instruct the memory, instruct the address bus to find the memory location, okay, to find the memory location that is intended for the start address of the instruction. When you start your program, you write in some memory location. For example, in the rack number 10, okay, rack number 10. So this is the start address of memory number 10, the start address of your program, okay, in memory or rack number 10, right? So what is the control bus? What does control bus do? Control bus, CPU send an instruction on the control bus stating that please read what is there in memory or in rack number 10. Read. Okay, so it's simply like that. Read or write. Control bus has this main function. Read or write. So when the CPU put the address bus, put the instruction in the address bus, fetch the starting address, then it sends also on the control bus, read. Please read it. Okay, so if you want to know more, please contact me later after this class. Okay, I don't want to interrupt the class too long. Okay, we're going to finish it. Memory address. Okay, we go back to this memory. Okay, memory address 0 until n-1. Okay, because why n-1? Because we started from 0. Okay, we start from 0. Okay, and memory is always read in hexadecimal. Okay, so please recall back how hexadecimal is being coded. Please understand it very clearly. In one memory location, okay, you can imagine that it has 8 slots. 8 slots means one slot is for 1 bit. So you have 8 slots means you have 8 bits. Okay, you have 8 bits. But bits is not counted does not start from 1, right? We start from 0 to 7. 0 to 7. So one memory location can occupy 8 bits of memory of data. Okay, it depends on what memory is this. Memory ROM or memory RAM. Okay, RAM or ROM. Okay, so and this is the most important part. So you have to understand is 1 byte is 8-bit data. 1 word is 2 bytes, meaning there are 2 bytes of data represent 1 word. Okay, how many bits are there? Okay, you can count it, right? 1 double is 2 words, right? So far so good.
Yes.
Right. Memory. I've just told you about this. Okay, so ROM. For ROM, it's a non-volatile memory, meaning that when you write the code, on the ROM, that's why this is program memory. Okay, you write the code. When you turn it off and turn it on again, the memory or the instruction is still there. Okay, the instruction is still there. You can still execute the program again. Okay, once you burn, as I call it burn the program there on the memory, on the ROM. Okay, it's still there. You turn it off and turn it on again, it's still there. That's why it's non-volatile. Volatile means meruap lah in Malay, right? I explain in Malay is meruapkan dia keluar macam tu, volatile. But this is non-volatile. Room. What room? What are you talking about? Oh, ROM. So the ROM is different than storage. They are different. They are the same. Storage is storage. Okay, but okay, it's just a terminology. Okay, put it this way. Storage. Okay, before that, I want to understand from your question. What do you mean by storage? Which storage are you referring to? Is it storage in the CPU or storage in somewhere else you're referring to? Okay. Yeah, it's actually they are different. They're actually memory. Okay, they're actually memory. Now, okay. For example, right now, let's focus in this one first. Okay, you can discuss later on. After this, I will open for question. If you want to ask more about other technologies, okay, we can discuss later at the end of this lecture. Okay. Okay, it's quite interesting because it's good that you know about ROM and RAM and stuff, other storage, okay? But we need to focus on the basic first, okay? Because we need to respect the others, okay? All right, so this is non-volatile memory. This is ROM. So for this, we call it read-only memory. It can only be read, okay? It can only be read by the CPU. Okay, that's why the address bus is being the instruction is being sent by CPU and it can only read from the memory. Okay. And for how about RAM? Okay, RAM. Okay, RAM is two basic types of RAM chips. Okay, dynamic RAM, static RAM. Okay, actually ROM and RAM, they all have technologies. What I mean is that, for example, just like your friend just asked just now. Okay, what is SSD lah, EROM, EPROM, EEPROM? There's a lot of ROM, right? What is it? What was the difference between them? They are all the same. They are all ROM. If it is ROM, it is ROM. If it is RAM, it is RAM. What's the difference between that? For ROM is that if you have EPROM, EEPROM is actually a evolution of technology of ROM. ROM in the first when it first started manufactured, okay, it can only be write once. Once you write it, you cannot erase it. Once you write the program, you cannot erase anymore. So you you need to buy another ROM, okay, and write on that hardware, on that memory. Okay, so this is ROM in the first generation. Later on, after that, the second generation, there comes the I think EEPROM or something. Okay, but there's an evolution of it. That's why we have EEPROM, erasable PROM. Okay, so that's why E stands for erasable, meaning that it evolves in the number of memory that you can write. Oh, sorry, how many times you can erase a program on it, and then you can write again. So as the times or as the years passes by, they comes up with a technology that makes ROM erasable and can be written on how many times. For example, 10,000 times, 100,000 times. Okay, that's an evolution of the ROM itself. So that's why they came up with a new name. It's actually a technology that it enables the number of erase and write. That's all. Okay, the function is still the same. Okay, for instruction to write the program, to write the code of program. Okay, so it stores the program that you write. Okay, how about now we're talking about RAM. Okay, what are two basic types of RAM? RAMs are dynamic RAM and static RAM. Okay, same. Okay, it's RAM. They are all RAM also called main memory. Okay, DRAM is a main memory, and this is for data. Okay, so remember, RAM is to store data, the value. For example, to do add operation, you need two value, right? 5 and 7. So 5 is being stored in RAM, 7 also is being stored in RAM. Okay, the memory, how the memory looks like, the same. Just like I told you, it's like stack of RAM. Okay, imagine in that way. Okay. Okay, so DRAM and RAM, so is this a technology? Okay, I've told you about this. Now, memory, data, and address bus. Okay, this is interesting. I've told you about this one. Okay, CPU can read a 24-bit address bus, but memory from here is reads 16-bit data bus. This is just an example. Okay, what does 24-bit address bus now means? Okay, now we move on into understanding how the address is being read. Okay, how the addressing, we call it addressing, bus addressing. Okay, bus addressing, meaning that like I told you, right? CPU, when it wants to write or when it wants to access the address inside the memory, it need to tell the address bus what is the location, what is the address, exactly, specifically what is the address, because there are lots of address here in memory, right? The stacks of huge of 2 to the power of 24 address bus, memory locations, millions, okay, millions of memory locations that is in the memory. So CPU need to specifically tell the address bus, because address bus has no intelligence to not to find, but to determine the address bus, but rather it only delivers, right? Delivers. So take the value from CPU, send it to memory. Okay, find it in memory, things like that. So let's look at this. Address bus is 24 bits. So the way we look at it is that this one is in hexadecimal representation, right? So hexadecimal representation of 000. So each of these hexadecimal is a 4-bit, right? 4-bit representation. So you can imagine that 4, 4, 4, 4, 4, and 4. So how many 4 are there? 6 times 4, 24 bits. Okay, there are 24 bits of 24 bits. Okay, 24 bits memory. So this is how you represent the memory. Okay, the memory location. So if it is 24 bits, meaning that you can arrange it in such a way that from 0000 until FFFFF. Okay, so how many number of locations are there? So to find the number of locations in the memory, you need to change it into decimal. Okay, decimal. So please remember. Okay, this one I need to write. I think I will. But I need to save it somewhere first. Oh no. Just give me some time. 1 minute. Oh, my computer is lagging. Please take a 2 or 3 minutes break before I continue.
Okay.
2 minutes lah, 2 minutes. 2 minutes.
All right.
My computer is like. I'm going to show you how let me check. Okay. How it is made, right? So tell me, why are you asking me to? Okay, for example, this is 8F. Okay, the content, the value inside the RAM is 8F, for example. So in any case, we want to know what is the memory, the size of memory here. We call it about size of memory. So when we talk about size of memory, we always write it in terms of kilobyte and byte, something like that, right? So can you tell me how many bits are there for this memory, for example?
2 bytes.
Somebody,
Is it
sorry,
12 bytes?
how many bits first?
Bits. Is it 12 bits?
How many bits are there?
I see 3, so 4 times 4 times 4 equals to
10.
2,
No.
2 bytes.
2 bytes?
Yeah.
Somebody says 2 bytes,
10 bit.
10 bits,
12 bits.
12 bits. Any other answer?
I think the memory have a standard, even 8 or 16 or 32 or 64. So we have to follow the standard or not.
9 bit.
Come again? I can hear you clearly.
I mean the memory have a standard for size, even 8 bits or 16 bits or 32, 64. So it has a standard.
That is bytes. Okay, you have to understand the representation. The representation for byte, that was byte. What we want to address is the bits first. Okay, later on we will tell you what has it anything to do with bytes. Okay, we can associate bits with bytes afterwards. Not now. Now I'm asking about bits first. Okay, how many bits? 12 bits. Any other answers? Okay, for this one, 2 bytes, he says, meaning that it has 16 bits, right? Correct or not?
Yes, one
Yes.
byte is 8 bits.
Right. But the answer for this question is 12 bits,
Okay.
right? It's simply 4 bits here. 4, 4, 4. Okay, 4, 4, 4. Understand? Okay, simple as that. So, okay, how we do that? Okay, so F is 4 bit, 4 bit, and 4 bit. How you represent it in? This is simply 0, 1, 1, 0. And this is F.
1, 1, 1, 1.
1, 1, 1, 1, 1, 1.
So that's why you can see you can get 12 bits here. Correct? So when you have these 12 bits, okay, what does it mean? What does it tell you? You can simply find the memory location as 2 to the power of 12. Why is it 2 to the power of 12? Because every single memory here is in a power of 2, right? So meaning that 2 to the power of 0, power of 1, 2 all the way until actually this one until 2 power of 11, right? But we want to know the full stretch of the memory. So we take 2 to the power of 12 minus 1. Okay, how to do that? Go back to your digital electronics. Don't ask me here. Okay, so if you haven't taken or you forgot your digital electronics, you always open back your digital electronic book, or else the best is to leave this course and take back your digital electronics class. Okay, all right. So this is how you get. So, but this one, when you calculate for this one, right? You get the value in decimal. So that's a value. I mean, there's a number of the size of the locations, right? But okay, but we always talk. But when in terms of memory, we always talk about bytes. Okay, we always say this is in terms of bytes, right? So in terms of bytes, how do we determine that? Okay, how do we start? How do we start now? Okay. So since this is 12 bits, okay, you have to understand that 1 kilobyte is equivalent to 1024 byte. Understand? How many bits is for 1 kilobyte? For 1 kilo, it is equivalent to 2 to the power of 10. Okay. For 2 to the power of 20, it is equivalent to 1 megabyte. Okay, which is 1024 times 1024. That's the value you're gonna get, right? So yeah, it's actually because it's this is index, right? 2 to the power of 10 times 2 to the power of 10. So this, since you have the same base, you can just simply add them together. So you get the 2 to the power of 20. So you get 1024 times 1024 bytes. All right. Yeah, and same goes to gigabyte. So 2 to the power of 30, things like that. So in this case, when we have a 12 bits, right? So can you guess what is in kilobytes? What is it in kilobytes? Can somebody tell me?
One kilobyte.
1 kilobyte. Okay. Any other answer?
Sorry,
1
sir.
kilobyte.
What's the question again?
The question is, since we know that this memory above there, okay, is 12 bits, right? So if we, because we usually do not say memory in terms of bits. We always say it in terms of bytes, correct? Just like what your friend just said. It has a standard. Yeah, standard. But do you know the standard? Anyway, so in bytes. So what is it in bytes? If it is 12 bits memory, what is it in byte?
1.4 byte.
Wow, very specific. 1.4 bytes. Somebody else?
0.01.
Where do you get this number from? I don't know.
Because 1 byte is 8 bits, right? So I don't know.
Okay, all right. Okay, good guess, but not exactly true. So let's look at here. Right? It's 12
Oh,
bits,
5.
right?
Okay.
12 bits, right? So 12 bits, I told you this is actually 2 to the power of 10 times 2 to the power of 2.
Oh, it's 1.5 byte.
So this is 1 kilobyte.
4
This is
byte.
for 1 kilo. This is for 2 power of 2 is 4. So it is actually 4 kilobyte. Simple as that. Understand?
Sorry, doctor, can you repeat this again?
All right. So, okay, let's take another number. Okay, so let's say you have a 13 bits. You have 13 bits memory. So how do you calculate in terms of bytes? Okay, sorry, obviously this is wrong. So the only answer is kilobyte. Okay, 13 bits. So you change it in terms of power. 2 to the power of 10, 2 to the power of, it consists of 10 and 3.
8 kilobytes, sir.
What? 8 kilobytes? Where do you get 8 kilobytes? Oh, yeah, yeah. So this one. Oh, okay, too fast. Too fast. Well, slow down a bit. Yes, this is 8. This is kilo. So 8 kilobytes. Correct. Okay. So understand that? So how about if you have about you have about 24 bits. So it is actually 2 to the power of 20 with what? 2 to the power of 4. Correct? You add them up and get 24. So this is 1 mega
16
and this
mega.
is 16 megabyte. Okay? Okay, everyone then no answer, so I guess it's okay. Alright. So blah 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 blah. These are the things, okay. Right, so this is another example. So like this one, okay, 2 to the power of 31 bytes. What does it mean? It means can write. I don't know, I can write. 2 to the power of 31 bytes, meaning that this is actually 2 to the power of 20 and 2 to the power, 30. 30 has 30 is for giga, right? So this one means 1 giga already. 1 giga, and this one 2 to the power of 30. Okay, and 1. So 1 giga times 2 to the power of 2 is 2. So this is 2 gigabyte. Alright, equivalently, this one, yeah, 2 gigabytes. Equivalently 2048 megabyte. Oh, it's interesting. I can actually write. Okay, nice. I hope everyone is clear about this. Okay, let's go back to. Okay, let's go to quiz 2. Oh my god, oh man. Never mind. I paste quiz number 2 here. Question. Okay, please answer quiz number 2 now. After that, we go straight to quiz number 3. One word. One word is, of course, it's one word is, 1 byte is 8 bits, right? 2 bytes represent one word, meaning there is 16 bits in one word. Okay, 16. Why is it different here? 16 and 16. So this is correct also. 16 and 32. 32 too much. 16. Correct. 16. There are 16. Instead, all three buses link to a CPU. Address bus, data bus, control bus, correct. Address bus, control bus, data, right, correct. Okay, I think everyone got it correct. It's just the way how you write it, right? But yeah, correct, right? Very good. Codes, the programs that you write in the microprocessor are stored in. This is very interesting. Stored in hexadecimal. Data RAM, correct. Data RAM is wrong. It's actually in ROM. No, address bus is just a bus. A bus that transport, that brings the value. But the program is stored in ROM. Only one got it correct. Isn't ROM? Okay, 2. 22 here plus 1 here, 23. Good. Okay, 24. SKE 32323 is when I don't have any memory with this name. ROM. Okay, correct. ROM. Okay, memory random too general. Any kind of memory? No, it's ROM. Okay. Okay. Programming C is even worse.
Mantul.
Instruction ROM. Okay, ROM. Okay, ROM. ROM. Okay. Okay. So you give me a lot of to choose from. So it's ROM, not RAM or ROM. They clearly do not understand this. Okay. When you write code, the code of the program must be in ROM. Okay, must be in ROM. Okay. What does ALU stand for? Metal unit. Okay, correct. Okay. Okay, so please guys, please revisit the slide and please understand again and discuss with your friend lah. Especially those who write it in SKE 3223 ni. It's clearly I don't know lah. How can you answer this? And C, not exactly. Maybe my question is not. It's not clear enough, or maybe my English is not good. So that's why you answer in programming C lah, hexadecimal lah. Okay, because I'm just thinking that you're going to answer in which memory. Okay. Anyway, so okay, let's move on to our third quiz. Before that, how many more we have in our? Let's look at here until where we should stop. I think. Yeah. Okay, let me finish my lecture a little bit. I think maybe the rest you will learn. You will need to read on your own. Okay. So next thing you need to know is that how the CPU or the control unit in the CPU executes. So the instruction cycle in CPU, it has this what do you call it? This operation. First, it fetch. Okay, it fetch. Yeah, okay, remember this. CPU fetch the memory or the instruction or the program that you write using address bus. Okay, it fetch. It takes. Remember when I told you about the CPU, the name of the guy is CPU. He wants to take a parcel from Jalan 2, nombor 2 Jalan Pulai Indah 5. Okay, so it needs to fetch, it needs to give the address on the address bus. So address bus just take the value, not store the memory, the program. It just take what address you want me to go? That is the job of address bus. So it goes to the address, fetch, and decode. Okay, it fetch first. So the address bus, the same address bus will bring it to a CPU. Okay, bring the address to CPU, bring the value to CPU, and decode the instruction. Bring the value, bring the parser to CPU, and then the CPU or the control unit inside it has the instruction decoder. Okay, instruction decoder. Let me show you here. Where is instruction decoder? We call it also instruction register. Okay, let's look at here. Here, instruction register is where the decoder or the decode instruction is being done. Okay, right? So first fetch, second decode. So after it fetch from the memory, fetch or which memory or which data should I go? So it takes from here, for example, then it bring it here, and then it decodes. Okay, first it fetch, and then it decodes. Okay, and then it runs or then it execute. Okay, third it execute. So execute means that when it understand what does 1141 do, okay, only then it will execute the operation. Oh, it says that I need to fetch data in memory 41 and put it in register and do add operation. So in this case, that take the value or the data from memory 41 and put it or move it into register number 1. So that is execute. Fetch, decode, execute. Okay, and there's another one, it's called store. Store, if there is an operation in between these two, it will store the value back into the memory. So what type of memory here? I'm asking you guys. Okay, so this one you can separate it into first, this is the upper part is the instruction where we put the instruction, where we put our program in. So the memory that stores our program is called ROM or RAM.
Rome.
Right. Okay, and this one, okay, this one is instruction register. The instruction register is like a dictionary. Dictionary that understand what does this code represent. So it has a lot of memory lah. It's like a memory, like a library to understand the dictionary. Or what does this one mean? So it will decode. Decode means it buka balik apa benda tu. So it reads back what is originally what it wants, right? So it try to understand because your code is stored in numbers, in hexadecimal. It translate the word that you write in numbers. It's not written in words. It is translated into numbers. And this one is clearly a data, right? Data is stored in RAM. So, okay, understand that? Okay.
Yes, sir.
All right, good. So, So, okay, this one please go through on your own. And okay, and the last one is please look at this. What are the modules or components that we have in CPU? We have ALU, instruction decoder or instruction register. Okay, it's quite confusing. Actually, instruction register and decoder is the same, The same. They are equal. Instruction register or IR and the instruction decoder, they are the same. Okay, and this is general purpose register, or often we use it as GPR, general purpose register, or the storage inside CPU. Okay, it's a small memory unit inside CPU. Okay, CPU cannot have a lot of memory because CPU is very expensive. Okay, so meaning that the cache here is very expensive, or the memory here is very expensive. Okay, because the closer the memory to the CPU, the much faster the operation will be. Okay, but if the memory is quite far a distance away from the CPU, it will take some cycle. Okay, some cycle to access and process the program. So that's why having a memory inside the CPU is very expensive. It is okay. That's why only important data is being stored temporarily here. So there's a catch. Is a temporary memory. Temporary. Okay, meaning that when you switch on, switch off, well, the memory is gone. Okay, and it's always rewritten. Okay, all
We
right.
have
So
class.
let's move on. Okay, we're going to finish the class, but last one. Last one, quiz 3. Sekejap. 47 now. Please, please, please. More. 49. Locking in. So, 0. Is there anyone anymore? No? Okay. In 10. Okay, no more. Okay, I think that's all. How many of us? 61. One more. One more answer. Not answering. Shy cat.
60.
There are 62 of us. Excluding me, it should be 61. So maybe one fall asleep lah. Maybe satu seorang pergi tandas ke apa. Okay, anyway, I'm going to lock lah. Okay, dah nak habis masa dah. So, dah habis dah masa. Okay, memory address. 12 bits. Very good. Correct. Okay, 12 bits. That means you guys understand. Okay, memory address. How many memory locations can be addressed? Okay, from it, you can have the 2 to the power of 12. So your answer is should be berapa? 2 to the power of 10 kan? So 10 means that you have 1024 times 4. So 4095. Well, okay, actually it's 4096. Okay, but
Isn't it? 2 to the n minus 1.
Okay, now that's a good question. Okay, 4095 is it's actually macam ni. Why you minus 1? You minus 1 is when you memory address. Okay, when you put the memory address, when you assign an address to it, then you start from 0, correct? Meaning that this is 0, 0, 0, 0, 0, 0, 0, okay, and UN is FFF, right? So if you count this, it is actually how many? You can simply
4096.
409.
Including the 0000.
Yes, including 00. So it's actually 4096
Okay, got it.
because starting from 0, because 0 is also a memory, right? A memory location. Okay, but if you say 4095, it means that you are as if you are calculating for the memory address because you start from 000 and then finish at 5FF, meaning that you have a 4095 because you exclude the 0. So that's why you have a 0, you have 4095. whereby actually it's supposed to be 4096. Okay, so that's how it should be. Memory address 200 to 3FF. How many memory locations? Oh, why very? Kenapa lain-lain ni? This is a good question, I know. How many memory locations? So how do you find it?
1024 minus 200, 824.
1024.
Minus 200.
You can actually do it this way. Okay, 400, 0400 minus 200. So you have exactly 200. Okay, 200 locations.
Sorry, how comes that?
Minus 1. Minus 1. So you have 1FF.
It's 3FF.
Yeah, I understand. Okay lah, put it this way. 3FF minus 200. So, okay, minus 200. So this is 1FF. Okay. But remember, you do not take into account 3FF. So you have to add in 1. Okay, sorry. When you write this, you have to include. It's already there. 1FF. So it's actually 1FF. Okay, 1FF is 0001 1111 1111. If you can, okay, let me share with you this one. Okay, I will solve it here. Okay, from 200 to 3FF, right? So what you can do is 3FF, you minus 200. What you get is FF, 1FF, correct? So this 1FF is simply, okay, 1FF is simply 1111, 1111, and 0001. Understand? So how many bits are there? How many bits do you actually utilize? You exclude this one. Okay? So you only utilize 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's only 9 bits here. So when you know 9 bits, then you can simply put it this way: 2 to the power of 10 minus 1. Understand this one? Why I put 2 to the power of 10?
No.
Okay, or else all you can do is 2 to the power of 9 straight away. Right. Okay? You get it?
2 to the power 9. 512.
Berapa jawapan?
512.
512.
512. So anyone got it correct? 512. So supposed to be 512.
Why did doctor put 2 to the power 10 minus 1? Is it the same?
2 to the power of 10 minus 1. It's okay. Kalau 2 to the power of 10 minus 1 berapa?
1023.
1023. Let me check. Oh yes, it's supposed to be 1023. 102. Wait. 1 minus 1. Yes, 1023. It's supposed to be 1023. Ada tak yang jawab 1023? 1023. Yes. Okay. This one. Very
Doctor,
good.
how come? Can you explain why?
Why is it 10?
Okay.
It
Alright.
says 9 bits.
Alright. Okay. It's like this. So you have 9 bits here, right? You actually fully utilize it 9 bits. Okay. But if you use this one is correct. This one is wrong. This one, the way I need the first answer that I give you, this one is correct. to the power of 10 minus 1 is correct. Okay, to the power of 9 is wrong, because if you write 2 to the power of 9, it means like it seems like this one is actually 1 0 0 0 something like this. 1 2 3 4 5 6 7 8 9. It's like this to the power of 9, which is wrong. Okay, okay, this is correct to the power of 9, but this is wrong. Okay, our value is maximum. We take the whole lot of 9 bits, so it's actually 2 to the power of 10 minus 1. Or what you can do is 2 to the power of 9 plus 2 to the power of 8 plus 2 to the power of 7, 2 plus 2 to the power of 6 plus 2 to the power of 5, 2 to the power of 4, 2 to the power of 3, to the power of 2, to the power of 1. Salah. Ni berapa? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. To the power of 0 kan? Starting from here to the power of 0. To the power of 1. Silap ni. This one correct. So, wrong. Let me do it again. Sorry.
What's the answer again? 1 0
Okay, let me check.
2 3.
Somebody influenced me. That's why I got it wrong. Okay, so to the power of 0, to the power of 1, to the power of 2, to the power of 3, 2 to the power of 4, to the power of 5, 6, 7, 8. So it's supposed to be 2 to the power of 9 minus 1. This is correct. Okay, not the power of 10, sorry. So, okay, the other way, if you can understand this way, it means this is to the power of 8, to the power of 7, plus 2 to the power of 6, plus 2 to the power of 5, 4, 3. You add them up, right? You add them, you still get the same. You still get the same. You add every single decimal value of this bit.
So the answer is 511 then.
511. Then yes, correct. 511. The answer is
But doctor, the -1 too. Previously you said it's referring to address. Now we want address location.
Okay,
So
you have to understand it in logic way also lah. Why I put -1? Because I nak cepat. Jawalan kerja dekat sini senang macam ni. Kalau kita terus ambil kat 29, kita tolak satu je, kita dah equivalent dengan benda ni semua. Faham tak? So ada two ways. One way is doing this, another way is when we do addressing. Addressing tu because we start from 0. This one also can be done in this way because we want to do calculation to find the decimal. Ini logic. Dan dia tak ada rocket science kat sini. Dia just logic je. You want to speed up the process? Yes.
Doctor, do we do 3FF minus 200 or 3FF minus 199 because 200 is a counted address? Like we're counting starting from 200. We're not excluding the address 200, right?
3FF.
So we should subtract 199 addresses, right?
We okay. If we subtract 200, so does it mean that we calculate? We exclude one of it?
Yes. I think so.
No, we actually include them together. We include them as one. Is the size of this one is 200 until 3FF. Actually, not 199. When you minus 1 from a hexadecimal, it's actually 1FF. Okay. So when you do this, it means that you take into account including the 200 itself. Okay, because 200 is the starting point of this, and this is the end address of this memory. This is starting address of the memory, and this is the end address of the memory. Okay.
Oh, okay, sir.
Okay. So this one is correct. You actually take that into the memory is all considered. Okay. So okay, yang tadi -1 tadi tu is actually basically just logic lah. Dia macam ni. Kalau 2 to the power of 8 until you add them up, okay, it will take you some time lah to finish lah. But actually you get the same 511. Okay. Faham tak siapa yang tanya tadi? I think because this is just maths lah. This is nothing to do with me. But if you for memory location, that one is a different story. Okay, for memory addressing, we will find it later on. Okay, so I hope everyone got it. Okay, understand it? So yes, 511 supposed to be 511. What is stored in Rome? Of course, blue is correct. Still some people, mana ni? 10 people got it wrong. They still do not understand that Rome is only used to store the program. Code, the program that you write, the code that you write. Okay. And RAM is otherwise. It's for the arithmetic and logic operations. Okay, guys. So with that, we'll meet again next week. Inshallah, the first things in the class, I will give you quiz about this topic. Just a summary of this topic. Okay, thank you. Any question? No more question, I hope.
I still want to ask the negative one, but tak apalah, I'll find myself.
What? Sorry, what do you want to know?
Why the first one tak payah negative one, but the second one you have to minus one.
Okay. Nanti you can talk to me afterwards, okay? Talk to me privately. You give me the question and I tell you what dia sebenarnya. How we do it, okay? Okay, those who cannot understand why subtype 1, why do you not have subtype 1, okay, you can arrange a meeting with me. You can open maybe a WebEx. You guys